We got a lot of great things to cover in cloud and mobile networking, such as Intro to Virtualization. We're going to look at how to create a virtual machine using Hyper-V. And we'll talk about cloud basics, what's going on in the cloud. And that includes all different kinds of as-a-service type products. And one of them would be platform and storage as a service. We'll also talk about storage when it refers to NAS and SAN devices. They sound alike, but they're totally different. We'll get into cell and digital phone service and mobile device deployment. And along with deploying mobile devices, you've also got to secure them. Let's talk about virtualization. What is virtualization? Virtualization is actually a lot more than just creating an operating system on another host computer. It refers to when we create a virtual resource. Now, it could be a server, it could be a desktop, an operating system, file storage, or a network. The main goal when we virtualize is to manage workloads using less hardware and creating more servers. By separating servers or workstations from each other, we can separate the load and also get rid of the possibility of having applications have issues with each other on the same operating system. Virtualization has been around for many years, and there's many different products. Besides Microsoft's Hyper-V, there's VMware, there's VirtualBox, and many others. Something new to virtualization, containers are the new virtualization technology. We can now virtualize applications instead of entire operating systems, and they can be applied to Windows, Linux, and Unix operating systems. Let's do a demonstration of how to create a virtual machine on a Hyper-V Windows server. So all we need to do to create a virtual machine is to right-click on the host and choose New Virtual Machine. And we get a wizard that pops up. And I'm going to call this Windows 10 Eval. And I'm going to put it into cluster storage. And cluster storage allows us to use the same storage with multiple different hosts. It's more of an advanced type of topic, but it's very helpful because it allows us to have high availability in case one of our virtual machine hosts goes down. I've selected my folder, click Select, and Next. And generation 1 and 2 is an interesting subject, and that's because up until 2008, all virtual machines used the same generation. Once 2012 came out, Microsoft made some improvements that allowed us to create what's called a Generation 2 virtual machine. And that gives us a lot of additional features, such as you see here, Secure Boot, SCSI Boot, Pixie Boot, and others. I'm going to choose that since we'll be doing Windows 10, which is after Windows 2008. I'm going to give it around 8 gigabytes of memory. We also have the option to use dynamic memory, and what this does is it allows us to use the minimum amount of RAM up until the maximum amount that we need. And it is good if you end up having a small amount of RAM on your host computer. In our case, we have a lot of RAM, so I'm going to use the standard RAM instead of dynamic memory because dynamic memory tends to be a little slower as it ramps up. I'm going to connect to one of our host adapters, which is just a network interface card in our host. And I'm going to change the size of our virtual machine from the default 127 gigabytes to just 50. We also have the option to install an operating system now or later, and I'm going to choose to install it now. So I'll just browse to where my ISO files are. And I'll choose my Windows 10 Eval ISO and click Finish. Now when the virtual machine boots up, it's going to give me the ISO file to boot from so I can install Windows. Before I do that, though, I want to right-click and go to Settings and take a look at my settings for my virtual machine. Now, this is pretty universal no matter what type of virtual machine product you're using out there. And some of these things are special to Hyper-V, but a lot of these things are pretty much the same, such as the amount of memory you can use. You can always change to more memory if you want. Processors. Most of these virtual machine products allow you to change to add more processors, and you can go to whatever the maximum amount of processors you have on the host. You also have the option to add a hard drive or a DVD, and in our case, this is a virtual DVD that we're extracting from an ISO file that we downloaded from Microsoft. And we have the network adapters. We see that there are 2, so you can add as many network adapters as you have physically installed. We also have some integration services, such as the ability to shut down the operating system from the host instead of just inside the operating system itself. We can also synchronize our time with our host if we want. Data exchange, heartbeat, and backup are all options. And then if we check the box for guest services, we also have some additional features there, such as copy and paste, volume shadow copy, and others. If we create a checkpoint, it's very similar to a snapshot in other virtual machine products, where it allows us to just go back in time to a previous version in case we had an issue. We also have the option for the automatic start and stop when the host machine has been rebooted. We'll apply those changes and connect to our eval Windows 10 and click the start button. When it starts up, it'll give us the option to boot off of the DVD, so we'll have to press a key to do that. And there's our option. And now we see the familiar Windows setup screen. The rest of the installation is just like you would see on any other physical computer. So let's go on to a computer that already has the Windows 10 installation done and see what we can do. And we're logged into our Windows 10 computer. I did make a few changes, such as changing the default screen, etc. But we see that we can run any program the same way as if we were on a regular physical computer. We see some options at the top, such as the option to turn off the virtual machine just by clicking this button. We can also click shut down. Now the difference is shut down is going to be graceful, like right-clicking on the start button and choosing the shut down and shut down option. Turn off is going to be like just unplugging it. Then we have the option to save it, and that simply sort of puts it to sleep for us, just like a physical computer might. And at the same time, it also creates the checkpoint that you see here. We'll click the start button, and it says it's restoring it back to where it was before we click the save button. And we see that our calculator is still running. Using save is a great idea if you want to create a quick checkpoint and you're just about to maybe install a new program and you're not sure how it's going to affect the operating system. So that's how we create and manage a virtual machine using Hyper-V on a Windows server. Let's cover the cloud basics. Cloud servers are hosted servers. They're simply servers, storage, and applications that are hosted by a company in another place. And they're accessed using the internet. You pay a monthly fee and you receive whatever service for which you sign up. There are many advantages to cloud services. You have eliminated the need to buy any new hardware. The cloud providers have all the hardware ready to use. You also don't need to buy software, as both hardware and software are ready to rent. This cuts out hours of figuring out versions of each and waiting for delivery. The physical security is much better because it's housed in another location, so there's no need to worry someone will steal your equipment, and two-factor authentication makes logging in secure as well. Setup is very quick. You can have a new server running within minutes instead of hours or weeks. There are also some disadvantages. The cost is many times that of buying your own hardware and software, and the cloud providers are very vague on what your bill can be until it's sent to you. It's all based on processes and usage, which can be difficult to calculate. If you have internet problems, the connection to your services can be very slow or non-existent if you have an outage. The virtual servers themselves may be slow as well if the cloud provider is having issues. Disaster recovery can be difficult. Some servers are not backed up by default. They are simply replicated with other servers. This can cause corruption to be replicated as well, and that would make it impossible to restore. If you use on-premise hardware and cloud backup, you could wait weeks for the restoration process to complete. A popular type of cloud technology is the Platform as a Service, or PaaS. So Platform as a Service is you pay and they take care of it. With Platform as a Service, you don't have to pay any servers or software or IT personnel. You don't have to maintain a data center either. Someone else is handling everything about the platform. All you have to do is use the product. With Platform as a Service, you have no control over what's happening. You don't employ any of the people. You're not in charge. You don't have access to the infrastructure. You're paying to have people handle that for you. That's one of the benefits of Platform as a Service. Software as a Service, or SaaS, is more specialized. This is generally software that normally we would have to run on our own servers or our own workstations. But instead, we're running that software somewhere else, out on the cloud, for instance. A good example of software as a service is something like email. Instead of having your own email servers and your own software that manage this process, you're instead using a third-party provider that's giving you the software as a service. The software and the service running somewhere else is in the cloud, and you simply use that to send your email. Infrastructure as a service, or IaaS, may also be called hardware as a service. And that's because we need hardware that's located in the cloud, but we're going to manage everything else ourselves. The customer is going to manage the devices and the operating systems and the software that's running on all of this hardware. But the hardware itself is somewhere else and is managed by someone else. There are so many more as a service that are being offered and are being developed and created every day. Some of these overlap each other and some are completely separate services, so it can be very confusing. So the best thing to do is to ask the provider exactly what they provide and what you need to provide besides cache. There's a couple of different types of storage that you can use out in the cloud that aren't installed in the servers themselves, and that's NAS and SAN devices. Storage area networks, or SANs, and network attached storage both provide networked storage. A NAS is a storage device that operates on files. The difference between a NAS and a SAN can be seen when comparing their cabling and how it is that they're connected. A network-attached storage device is simply used to share files and folders in a way that you can share files and folders on a Windows server, but it really doesn't provide any other service. There are some NAS devices that have added additional services, such as QNAP, that go beyond a simple network-attached storage device. For instance, some QNAP devices provide NAS services or SAN. You can pick between the two from the website options. They are Ethernet connected, so you're going to have to connect to them over the network. They're not physically connected using a fiber cable or SCSI cable or anything like that. There is a built-in operating system, and it's usually Linux. Microsoft did attempt to have a network-attached storage device operating system at one point, but they decided to stop selling it. They are generally inexpensive. You can find a NAS unit for as cheap as a couple $100 or as expensive as $50,000. It all depends on what's in it, how much storage, and how much processing power. A SAN, or storage area network, utilizes many different types of connections. You can connect to it by using Ethernet, such as iSCSI, fiber, a SCSI cable, which isn't as used as it used to be, and SAS, which stands for Serial Attached Storage and has its own proprietary cable. Instead of being attached to the network, you attach these cables directly to the server for which you're working on. Now, it is possible to have a dedicated switch if you're going to connect multiple servers to the storage area network, but you typically do not leave this connected on the same switch as the other hosts, mainly because they use something called jumbo frames, and those frames tend to really slow down a standard switch. They're also a lot more expensive than a network-attached storage device. You can get them anywhere from a few $1,000s up to hundreds of thousands of dollars. Here is a computer network that's connected to a switch and a network-attached storage device. So you would log into a web interface or command line on the NAS, and you would set up files and file shares, copy data to it, and then the computers on the network would then connect to it as needed. And you would set up security in a similar way you would do to Windows, except for it's not nearly as granular. You're mainly going to see just full access, read-only access, or read-write access. You're not going to get the granularity of Windows that gives you all different points in between. On a storage area network, it looks a little bit different, as you see here. You see computers connected to a network switch, and then you see a server. And then you see a storage area network device, or SAN device, connected directly to the server as well. And that server will connect to the storage area network using any one of those connections we talked about, and they can show up as drive letters on the server as if they were internal to the server itself. So the operating system can't really tell the difference between storage that's external or internal when you use a storage area network. When we talk about networking, we have to start including cell and digital phone service. And that's because they also operate now, when you have a data plan, on the TCP/IP internet. There's many different types of cellular phone service, and GSM, or Global System for Mobile Communications, was very popular in the early 2000s and was used mainly by AT&T and T-Mobile. It was very effective at voice communication. Data services were not intended in the design of GSM. The way it would work was that each person shared a cell line with many other people. To keep it from running into each other, each caller would have their own slice of time. It caused a lot of delays and other problems, but it did work mostly fine for voice. It was circuit switched, which means that the calls hopped from one circuit to another using analog signals. This was 2G or second generation service, and towards the end of that service life, a digital to analog conversion was added, which added minimal data transfer capabilities like we see today. 2G had great coverage. 90% of the US was covered because the technology was very mature and cheap to deploy. It was also deployed in other countries as well as continents such as Europe. A great advantage of GSM was that you could move your SIM card from one phone to another anytime you wanted. Here's a graphic of what the circuit switching looks like, where the calls hop from one circuit to another using these analog signals. So we would call this cellular communication, which was analog. And you can see that phone A conversation would go first, followed by B, followed by C, and then A would get another slice of time, followed by B, then C, etc. You could get a lot of choppy calls if you had 100 or more phones all connected to a cell tower because they each had to get their own slice of time. Another type of cellular phone service was CDMA, or Code Division Multiple Access. And it was very popular with Verizon and Sprint. And it used multiplexers for discrete communication. And that allowed us to divide the signals so each user had their own private code connection. Instead of sharing time with one stream, they each had their own discrete one. There was far less coverage with CDMA, but generally the call quality was better. Neither GSM nor CDMA could easily handle data packets. This required a packet switching network like we use for our internet connections. A disadvantage of CDMA was that you couldn't switch phones because the CDMA code was programmed into the phone and there was no SIM chip. Here's an example of CDMA. You have A, B, and C phones, and they all have their own separate lines. So you can imagine how much better call quality that was. And there were all types of cell phone wars on the commercials on TV, and Verizon and AT&T constantly fought with each other. And basically what it came down to was CDMA was better for call quality, but AT&T had better coverage for 2G GSM. Mobile phone providers have moved towards what we call 4G and soon 5G. 4G was also known as long-term evolution. It never actually met the 4G standard that was submitted to the IEEE, so the 4G term was just a marketing gimmick and not ever reality. True 4G would have required gigabit connectivity. This is a converged technology, so we no longer have to worry about a provider giving us GSM or CDMA. It allows us to completely and seamlessly communicate with voice and data at the same time over the same network because all providers have changed to a digital packet-switched format. We can now do voice and data so much better and faster. The original LTE standard supported download data rates of 150 megabits per second, and the latest version of LTE has doubled that to up to 300 megabits per second, although no one's actually going to ever see that fast of a speed because you have to share that speed with everyone else on the cell tower, and you'd have to have line of sight in order to get the best possible speed. 5G is being deployed, but even after the hardware is deployed out on the streets, it's going to be a while before all the phone companies will cut over to 5G because they want to make sure that as soon as a client or customer gets a 5G phone, they'll be able to use it. And until all of the cell towers are upgraded or replaced, you're not going to be able to do that. But I'm sure it won't be long before we see 5G in the market. Mobile device deployment is all about pushing out what you need for security and functionality to your staff using a mobile device deployment software or hardware piece. So, mobile device deployment can include BYOD, bring your own device. This is where an employee brings their own personal phone and uses that for corporate use as well as for personal use at the same time. Usually an organization will require that the phone has at least met the minimum requirements, such as a certain version of the operating system or a certain level or patch level of the OS as well. From a security perspective, it may be difficult to manage one of these devices because it contains both sensitive corporate data as well as someone's personal data on the same phone. It is possible to use tools like group policy to mitigate some of the issues if you've deployed Active Directory, but you still may not be able to completely secure it using this option. Another way to go is with corporate-owned, personally enabled, or COPE. This means that the organization purchases a smartphone and then it's used both as a corporate device and as a personal device for the end user. The organization is going to maintain full control of the device. Usually it's managed through a centralized mobile device manager, either in Windows or some other third-party software, similar in a way that we used to manage BlackBerry phones in the early 2000s. Anything that's stored on this type of deployment is under the control of the corporation, which means any information on the device could be deleted at any time by the organization. That makes it not very popular with the staff because they end up having to have two phones, one for personal and one for business. Another option is choose your own device. Just as in COPE, the organization would buy the phone. However, the user would have the ability to choose which smartphone works best for them. This not only gives the organization control of the phone and all its data, but it raises the morale of the users due to the ability to choose. It's still being personally used, however, and that could add risks. Another option is the corporate-owned model. The corporate-owned model takes security to the next level. The organization has purchased a smartphone, they own it, and they control all aspects of it. Unlike previous models, the corporate-owned model does not have any type of personal use enabled. If you need your own device, you'll need to purchase your own and carry a separate one with you. This type of deployment model is obviously one where security is extremely important, and they don't want your personal data mixing with the corporate information. Another option is the virtual desktop and virtual model infrastructure. This option is related to the infrastructure as a service model rather than a deployment model. VDI and VMI are very similar to using remote desktop on a PC. VDI stands for Virtual Desktop Infrastructure, and VMI Virtual Model Infrastructure. You use an application where you log into a server, but this time you do it from your phone. And once inside, you see a new screen with all the approved applications you can use to do your job. This can be either privately owned or corporate owned. The data isn't even on the smartphone. It stays on the server and it's backed up there as well. So if the phone is lost, there's no security risk since it requires two-factor authentication to log back in. Neither of these will be obvious to the person who stole the phone, so no client data can be compromised. Let's talk more about mobile device security. In certain organizations, it makes sense to take advantage of a mobile device manager. These are available for Microsoft, Cisco, and others. Using an MDM, you have total control over the smartphone and you can set policies to allow or disallow features such as the camera, texting, applications, and more. You can also set browsing policies using white or blacklists so they only go to allowed sites. You can force a secure password to be required in order to access the phone instead of using no password, which would be default. Another type of control is the ability to push out applications. Let's take a look at this further. A choice you'll need to make is whether or not to allow access to the store to be able to download applications. There's many malicious applications out there where users can be fooled into downloading and installing them. So a good idea is to install anti-malware onto the phone to protect against malware should it accidentally get installed. This will add to the cost as well as the management. However, enabling encryption also helps if the phone is lost or stolen. The memory can't be separated from the phone to be able to view it and steal someone's identification or client data. You could also use cloud services like SharePoint or Google Drive to keep the data off the phone itself. Data loss prevention is a feature that should be turned on because it can block the ability to copy and paste data off the phone and sent by email or other means. With mobile device management, you have total control over the phone and all it can do. One thing that you should set up is a remote wipe capability in case it gets stolen. So from your server or website, you can erase everything on the phone and then disable it with your phone company. A lockout policy will keep thieves or former employees with BYOD phones from guessing the phone's password too many times. And this can trigger an auto wipe just in case that happens. Geolocation tells you where the phone is if you think you can retrieve it. Geofencing will block certain features, such as the camera in the phone, from working outside the organization's location or in sensitive areas. For employees to access the phones, they can use the standard passwords, but there are alternatives. One would be a thumbprint to unlock the phone. This has been found to not be the best security, so you could tie it with a password. You can do the same with facial recognition, which by itself is not that great and has been known to be vulnerable. Screen draw allows you to draw a pattern. With screen lockout, this could be very effective. You can also add the need for a key fob or other device to add two-factor authentication to the phone. To summarize, we talked all about mobile devices, storage, cloud, and virtualization. These are all very useful things to know for an IT administrator, and also a big help as you prepare for your Network Plus certification test.